The most common place to encounter a logical test is in an application process for a job or a school. The logical test is used as one of several assessment mechanisms, and the result is often communicated in the form of a percentile. You may have seen the chart to the right, which is one example of different percentiles. For this purpose, a percentile simply means how your performance compares to others who have taken the same test. If you are in the 50th percentile, it means that you have scored better than about half of the test takers, and the other half have scored better than you. As the chart suggests, most of the people end up scoring somewhere in the middle, around the average score, and scores closer to the maximum or to the minimum becomes more and more rare. Many companies apply a minimum threshold as a hard requirement. This means that you need to score at least the minimum threshold score in order to proceed to the next round in the recruitment process. This minimum threshold may vary depending on the job you're applying for, but common ones are above the 30th percentile, as you can see in the chart, and above the 50th percentile, which essentially means that you're above average. There are some slight variations to these logical tests that companies and schools want you to take as a part of their recruitment process. But the most common type is what we call the sequential test. Based on our experience, this is the type of test that you will see 9 out of 10 times nowadays. In this example, we see 9 boxes organized in sets of 3, where one of the boxes is a question mark. We're also given some alternatives below, and your task is to figure out which of the alternatives should replace the question mark. In this case, it's D. Many of you saw this right away, as this is a question of lower difficulty. If not, don't worry. By the end of the video, you will. Test makers and companies like to market their tests as some sort of true measurement of intelligence. And I have very often heard things like, there's no point in preparing for the logical test since you cannot improve your score by practicing. This is simply not true. You can absolutely improve your score with the right preparations and practice. I will in fact show you how in a second. You may not be able to improve from a bottom percentile to a top one, but if you are somewhere around the 20th percentile, you have all the chances in the world to improve to the average percentile. Or if you are already performing average, you can easily improve to above average by learning the right toolbox. And given where the companies usually set their minimum thresholds at, this is the difference between receiving a rejection email and proceeding one step closer to being offered the job. The conclusion here is that don't listen to anyone telling you that you can't improve on logical tests, because you can, and I will now show you how. I will now teach you the QPR framework and the method I use to consistently score in the 90th percentile or better. All logical tests build on a few fundamental concepts. These concepts represent the different ways test makers can design their problems. By learning these concepts, you will learn how to think like the test makers and be able to use their tactic as an advantage when solving the problems. Imagine a simple triangle. The 3 corners represent the 3 most common ways for the test makers to design a problem. 3 different concepts. The first one is quantity. In this example to the right, you see 3 boxes with white circles in them. We can all see that the boxes from left to right contains 1, 2, and 3 white circles. This is a simple example of the quantity concept. The second concept is position. In the example to the right, you now see the same 3 boxes, but this time there's only 1 white circle in each box. We can also see that from left to right, the position of the white circle also moves from left to right. In contrast to the last example where quantity was the concept that mattered, now it's the position of the circle that follows a pattern. Almost all logical problems are built on either the quantity concept or the position concept. And on questions with lower difficulty, you are very likely to see either a quantity pattern or a position pattern, or a combination of them both. The third concept is reaction, and this concept is often introduced in problems of medium to hard difficulty. Reaction deserves its own introduction, as the complexity is higher than for quantity and position. Reaction means how symbols or patterns interact with each other when they overlap or combine. You can think about reaction as what happens when two things meet. And typical reaction patterns that you will see in logical tests are the override pattern. For example, when purple meets pink in this example, pink is the stronger of the two and pink survives. Pink overrides purple. Another pattern is the transform pattern, which is also common. In this case, two purple squares meet, and they become a blue square. Purple transforms to blue. The third common reaction pattern to be aware of is the cancel out pattern. Just like in the transform pattern, two purple squares meet, but instead of becoming a blue square, they cancel each other out, and the result is blank. If you master these three reaction patterns, you're in good shape for any questions based on the reaction concept. Let's look at a full reaction problem to really make sure that we understand this relatively complex concept. You now see 9 boxes in sets of 3 in the bottom right. The boxes have white and pink circles in them. The last box in the bottom right is a question mark. Our task is to figure out what should replace the question mark. For those of you who want to try to visualize the correct answer, this is a good time to pause the video before we have a look at it together. I will also give you a hint. All right, let's break it down together. The pink circles seems to be static and always stay in the same position. But the white circle moves from left to right horizontally and from top to bottom vertically. In the middle box, there is no white circle. Based on the position pattern, the white circle should be in the middle position of that box. But in that position, there is already a pink circle. Here, white meets pink, and based on the middle box, pink seems to override white. When looking at the box with a question mark, the position pattern suggests that the white circle will be in the bottom right corner. However, the second pink circle is already there, resulting in white and pink meeting again. We learned from the middle box that pink overrides white, giving us a solution that looks like this. The reaction concept is the hardest one, but by learning and mastering that, you will significantly improve your scoring on the logical tests, as you will be able to correctly answer problems of harder difficulty. The QPR framework gives you a guide in what to look for and what questions to ask when solving logical tests. The ultimate goal is always to identify what rules test makers used when creating a problem, so that we can apply them as a solution. And in the QPR method, these rules will be based on either quantity, position, or reaction. Now when you know the QPR concepts, let's look at how you can use them step by step to solve logical problems. When faced with a logical problem, always start with the quantity concept. Check for patterns and identify rules. Then move on to the position concept. check for patterns, and identify rules. And last, analyze the reaction pattern. The reason for always starting with quantity and position is that the reaction concept is dependent on there either being a quantity pattern or a position pattern. In the QPR method, there cannot be a reaction pattern without quantity or position. And to correctly identify the reaction rules, you need to first know the quantity and position rules. Let's now apply the step-by-step method to the problem we just looked at. The first step is to identify any quantity patterns. In this problem, there's no quantity patterns. Most of the boxes have 3 circles, but the middle one only has 2. There's no clear quantity pattern visible. What about position? As we learned earlier, there is a position pattern in this problem, where white circle moves 1 position with every box movement, while pink circles are stationary in the middle and lower right corner. Based on these position rules, are there any overlap of symbols? Yes, there is. We talked about the pink and white circles meeting in the middle box. And we have also identified how the pink circle overrides the white circle. Now when we have identified the concepts and the rules for this problem, the last step is to apply the rules as a solution to the problem. And here's the solution again. The rules are telling us that the pink circles should remain in their positions while the white circle should be positioned in the lower right corner. But because of the override pattern, the white circle will not be visible. The pink circle will be instead. Now that you have your QPR toolbox, let's apply it to some real-style problems. Let's start with a problem of lower difficulty. This is the type of problem that you are very likely to see as one of the first ones on the logical test. Remember the steps. Start with quantity and position, and then look for reaction patterns based on what rules you have identified for quantity and position. This is a good time to pause the video if you want to give it a try before we solve it together. Alright, let's start with quantity. Is there a quantity pattern? There's no increase or decrease of the arrows, and all the alternatives we get each has 1 arrow. Quantity does not seem to play a key role in this one. What about position? There's definitely some sort of rotation of the arrows. This problem seems to care about position. Let's identify the rules. To find the rules, let's start from left to right. Here we can clearly see some sort of rotation of 1/8 clockwise. What about from top to bottom? Here we also see a rotation of 1/8, but this time it's counterclockwise. What about overlap of symbols? There's not, right? The arrows are never overlapping with each other in this problem. So this problem seems to be all about position of the arrows. By applying our rules for position, we can clearly see that the solution is E. Let's look at another one. This one is a little bit more difficult, but these types of problem with medium difficulty, I would argue, are the most important ones for you to be comfortable with. If you are struggling to reach that above average requirement that many companies use, it's likely that you get these types of problems wrong. So spend some time on this one, use the QPR method, and give it a go before we solve it together. This is a good time to pause the video. Okay, let's start with the quantity. Do we see a quantity pattern? At first sight, there does not seem to be any quantity pattern here. From left to right in the top row, we see the 2 first boxes with 1 star each, and then the third box having 2 stars. The middle row, from left to right, has 1 star, followed by 2, and then 3 stars in the right box. We cannot analyze the bottom row of boxes as this one contains the box with a question mark. Similarly, if we look at the vertical columns, the left column starts with 1 star in the top box, followed by 1 in the middle, and then 2 in the bottom box. The middle column contains the question mark, so let's skip this one. And the right column has 2 stars followed by 3 stars and then 5 stars in the bottom right box. Seems like no clear pattern based on quantity. However, as some of you have already figured out, the last box in both the horizontal and vertical sequence contains the sum of the 2 previous boxes. So we do actually have a quantity pattern here, with the following rule. The boxes in the right column all sum the number of stars in the 2 boxes to the left. Similarly, the boxes in the bottom row all sum the number of the stars in the 2 boxes above. And this is an example of a higher difficulty quantity concept. Quantity is not just about increasing or decreasing quantity. The harder problems will also manipulate quantity based on addition, subtraction, and sometimes even multiplication and division. So keep an eye out for this as well. What about position? Is there a position pattern? There's not the normal change in position that we saw in the last example. However, if we look at the positions of the stars in the boxes in the right column and in the bottom row, which are the boxes summing up the stars from the 2 previous boxes, we can see that the stars in the summed up boxes are keeping the same position as they did in the initial 2 boxes. So yes, position matters. The stars are not just randomly placed out. What about reaction? Do we see any interference or overlap of symbols based on what we now have learned from the quantity and position? In this case, the answer is no. In this problem, we are dealing with a combination of the quantity and the position concept. Let's now apply these rules to get to the answer, which is C. Let's now jump into the last and most difficult problem. This is the type of problem you need to be able to solve if you want to score above average. Pause the video and see if you can solve this one before we solve it together. Alright, quantity. Do we see a pattern here? There actually is a quantity pattern here, but it is a little bit harder to see because of the reaction concept, which will play a key role in this problem. The quantity rule here is the same as in the last question, where the last boxes from left to right and from top to bottom sum the circles from the 2 previous boxes. The position pattern and a rule is also identical to our last example, where the circles in the summed up box are keeping the same position as in the 2 previous boxes. At first sight, the quantity and the position rules did not seem to be identical between the 2 problems, and this is because of the reaction that we now need to consider for this problem. When we now try to identify the reaction pattern, let's look at the top row from left to right. According to the quantity rule, the 3rd box should sum up the white circles from the previous 2 boxes. And according to the position rule, the white circles should stay in the same positions in the 3rd box as they did in the 2 previous ones. When we apply these rules, we notice that 2 of the white circles will have the same position in the 3rd box. I have highlighted them pink here to make it easy to follow. In the 3rd box, these 2 circles interact with each other. They meet. And the reaction that happens in this problem is the cancel out pattern, where 2 symbols becomes a blank. So the reaction rule in this problem is a classic cancel out pattern. This is a very common pattern in questions of higher difficulty. Now when we have all the rules identified, pause the video and see if you can find the correct answer. Which is B. Notice how the difficulty immediately went up as soon as the reaction concept was introduced. Not only did it add an additional step and a rule, it also made it harder to identify the quantity and the position rule. Let's wrap this up with some key notes I want you to remember. Logical tests are only one factor in the admissions process, and there is usually a minimum threshold that you need to make. You can improve your score by practicing and applying a structured method, such as the QPR. Logical tests rely on a few concepts: quantity, position, and reaction. Start each question by identifying the concepts and the rules of the concepts. Then apply these rules as a solution to the problem. QPR is a simple and straightforward method, and it works very well on logical tests. Test makers don't want you to practice, as this would jeopardize the credibility of their tests. There is a very limited amount of good practice material out there for that reason. Based on hundreds of logical tests, we have created a comprehensive practice set, which we believe is the best material out there today. You will find the link to this along with the free QPR cheat sheet in the descriptions of the video. Thank you so much for watching. If you enjoyed the video, please like and subscribe, and good luck with your test taking.